So this is a conference within conference, and I'll first have a keynote, and then we'll get on to the main stuff. And there'll be multiple sessions, one on Clojure, one on Scala. The Mirah one got cancelled because Charles did most of it yesterday. So, so slight change here. Uh, everyone up, right? All right. So the talk is JVM or polyglot programming on the JVM via JRuby. I'm Ravindra Jaju, and some bit of information about me. Twitter handle and GitHub handle are the same. I work for Industrial Logic as an agile coach, as a developer as well. And yeah, just a quick plug is like we are a bunch of um, hackers and professionals who who do training for the enterprise for companies. All right, so here the keynote ends. And this fine print is like now it's over to the Emacs, the shell, and the browser with some help from Vim. Keynote ends. Yeah. All right. Here. So. Oh. It's in 1024. Okay, some malfunction. So I'm going to restart Emacs. It's the display which kind of. All right. So here. So that's my list of things to do. Is this better? All right. So we start off with the introduction. I'll give you a very quick thing. So what's the motivation for talking about the JVM, rather polyglot programming here? And if the answer is supposed to be one word, it's the JVM. Okay. And if I have to really get into details about why the JVM, then let me just quote David Wheeler. He said, all problems in computer science can be solved by another level of indirection. Print goes out, sorry. So anything you see, just introduce one more level of indirection. It seems like we have a totally new way of solving very tough problems in apparently very simple ways. So while Java, the language, has somehow, at least might be good to hear for most of us, but not maybe for some, has outlived its utility as a replacement for C++, the language. The JVM has been evolving pretty well. It's an awesome piece of work, awesome piece of engineering. And even if you don't want to take my word on this, indirectly you can infer the importance, the awesomeness, the hotness of JVM by looking at the kind of languages that have been implemented on the JVM, and they're all very much in vogue, in use. There's like big throbbing community for each of these languages: JRuby, Clojure, Scala, JavaScript. It's the Rhino engine as we call it, Jython, Mirah. So what we cover will be a quick overview of JRuby's Java underpinnings. So in the end, if you look at JRuby, almost anything would have a representation inside of the JVM as a class at runtime, right? And it's Ruby. It's just the object representation, the class representation on the JVM. The JVM doesn't care, doesn't know whether it's Ruby or whether it's Java or anything else. It's just the bytecode. So what that means is that irrespective of the language that you're using, whether it's Clojure or Scala, JRuby can, or any language or any runtime can actually access any other class that is loaded and look at it at exactly the same as it would look at any other class, right? So it makes interoperability very straightforward. So as you see, I mean, I've covered all the 3 points here. What we won't cover would be any language, any other language in depth really. And I'm not going to make any assumptions about your experience with any other language really. I mean, mostly knowing Ruby and O should be good enough. But okay, I'll take some liberty of showing Clojure code here because there was some good response to Clojure code yesterday. And it's not, I mean, it's just going to be a couple of lines there really. So, I'm sorry, I'm just a bit nervous here. All right, this is, sorry, not done. Clojure. You all know it now. At least we do. It's a Lisp on the JVM. Scala is a multi-paradigm. You introduced a word in your talk. Can't recall what, but that was your contribution. You said to Scala. Omni-paradigm. Omni-paradigm. Yeah, right. So it's an omni-paradigm programming language. It's O plus functional for you guys. Mirah is it's not completely Ruby, but it's statically typed Ruby syntax. And then there's Java, of course. So that's done. Now let's look at Clojure. Okay, some fun stuff. All right, guys. Thank you. Here, looks like Ruby code, right? Once more. What is this? Any guesses? If people have been following the Clojure community closely, you might know of something. All right. It is so there is a library in Clojure called Overtone, and it's a library for creating nice music in a very functional manner. So if you look at the code used to create music there, I mean it's programming, music, all going together, and it look. I mean I'm not a music guy, but I think I'm very excited when I look at Clojure code which can generate music. Wow. So this is Ruby calling Clojure code. Like that's just a simple example. We'll come back to this. For that, why does it always go out? Sorry, just a small hack to split into two and hoping that this lower one shows. Okay. So the idea is, okay, well, coming back to Clojure and away from the example, Clojure focuses very strongly on immutability. So there is consistent use of what are called persistent data structures. Persistent data structures are very efficient implementations of immutable data structures in a way. The immutability comes from, let's say it appears to be immutable to you, but behind the scenes a lot of interesting structural sharing is going on, which allows for multiple people, multiple users to use the same, most of the same data with some deltas managed here and there to get their own views built efficiently on top of the same basic structure. So when you talk of immutability, it directly plugs into the idea of doing easy concurrency. The problem with concurrency is always how do you share data, how do you manage state, all that stuff. So There are a lot of good abstractions available in Clojure. What I want to show you next is some Ruby code now, where we won't get into what gem I'm using right now and what not. I'm just going to show you some wrapper code that has been written in Ruby so that you can call into Clojure. I'm sorry, this is 1024 by anyone? I set for 1024 by 768, but somehow anyone knows how to. No, I think it will screw up the window.
No, no, it's on. It's
Oh, okay. I can switch it, right? 1024 by 768. Yes. Okay. Uh, Forget the. I would say just don't uh, be concerned too much about the setup there. I'll quickly walk you through is the fact that I include a few jars into my class path, which can be done from outside, but this is just to give you a feel. And this is the JRCLJ gem uh, that you include. You see this JRCLJ gem? Okay, so there is a JRCLJ, there is a Java to Ruby bridge gem created. We can use Ruby goodness here. It doesn't, let's say, have this function, so I open it again, add a helper method there for me, which, okay, the name is eval string. I wanted to, I just use a short name because I didn't want to get into the other problem, the hardest problem of programming, that is getting the variable names right. So I thought let's not get into hard problems right now. And then I have some string which is Clojure code, and I have a class RubyFun which is Ruby. If you look at the first line there, it includes the interface ifn from Clojure. So that's Clojure library. So what is the idea? So going back to the uh, the JVM stuff here, how does Clojure run? So when you write some code in parentheses, the first argument is actually a function, right? In Lisp, the first argument is a function. So if you look at def fun, the string there, do seek, it's a function or a macro, but in the end it will expand to something which where the first argument is a function. Okay. Now there are no freestanding functions on the JVM. So how does it work? There is an ifn interface that encapsulates some logic, and that is supposed to have a few methods implemented, right? They are apply to and invoke. They work for our purpose here. Apply to and invoke. All right. Now I can take an instance of this Ruby class, pass it on to Clojure, and make Clojure execute this. Right? Am I clear on that? Right? So we can make Clojure execute Ruby code. Why we might want to do that? That's where we are going to come next. All right. So that's a function which is going to play that sound again. So I have an instance of CRLJ in C, eval string and fun. then I can do I wrote a helper there. It's a Ruby object whose invoke has been called. Correct? I put in a sleep, some sleep time there. So you see it returns after a small while. Alright? Now, you want to use something called a future in the Clojure language. What does future do? Future is another nice function which will take a function that you give to it and execute it elsewhere in another thread. Alright? How does that help us? Now let's say I wrote this small wrapper which only adds the future thing before and after a parenthesis after, right? To Ruby fun. Now I can do, you see it immediately returned, and that function was invoked in some other thread. Correct? Once more. Right? Are you with me until now? Any questions until now? Okay. So how many of you don't like this sound? You don't like it. Great. At least I have one customer. So, you know, I want to give a demo, but I want the demo to be cancelled at any point in time if my customer doesn't like it. So here, you'll have to listen to it just once because I type much slower than this thing executes. So I have a handle here, let's say. Okay, this time it does nothing, but here. I got a handle to something that's executing in another thread. You don't like it? Okay, I cancel it. Okay, so this is what Clojure gives me for free, and I can use it from Ruby. I can do the same stuff for the Ruby function. Unfortunately, it doesn't seem to cancel what's execute in the thread thing here. But you could hand it over to, let's say you have tasks that you want to hand over to other threads, and then you want to have some. Okay, so I'll show you one more thing. So there's this method on the handle called realized. The realized method tells you whether a computed value has been realized from the function that you asked your Clojure runtime to execute. So where do you think you can use this? I can think of many cases. For example, let's say I have a web application and I need to generate a lot of content by talking to many services which are distributed all over my network. But let's say you're a Google, right? You show results, you show search results, you show image results, blah 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 blah, all of them. But you don't really care if one of them actually does not show up completely, or whether you computed 1,000 results or 10,000 because you're only going to show just a few, right? So let's say you get a request, you just spawn off a few of these things in their own threads. You do your own local computation. At the end of it, you have a timeout and say, okay, whatever has not been realized, I can go and cancel them. Cancel, collect whatever you have in your hands, create output, and then that's it. Like, you're done, right? So how many times? I mean, I have personally faced this many times. But how many times would you have had this situation where you had to call external services? Sometimes the service was like very slow in responding. That led to maybe slow response of your web application, people complaining, all of them, right? How many of you have faced this issue? So I'm not suggesting this as the solution for that problem, but what I'm saying is that's one possible approach. Maybe not in a web app, but maybe something else, right? All right. Okay. Coming to, I think I'll skip some more variations of this example and actually take you uh, straight to the transactions example. So, I mean, uh, how many of you have heard of STM? Great. So STM is software transactional memory, where you can do some computations in memory, which, if they fail, you could roll back to a previous known good state. All right. So that's very common stuff in databases. But can you do that in your code, in your running code? Okay. So there are STM libraries available on the JVM. So Clojure has one. There is the multiverse library. I want to show you something. All right. Uh, so here I I use the Clojure gem that Charles has written. We define an account. This is a bank account, which extends from Clojure object. It's not the Clojure object thing, but it's a Clojure ref. We have a initial balance in the account. We have a withdraw method and a deposit method. Very simple, right? You have an account, you can withdraw money from it, you can deposit money to it. And there's some checks. If the amount that you want to withdraw is greater than the balance, then you raise a string. And if you deposit something, just can't be very smart, right? I mean, if you're depositing something less than 0, then you're a cracker. I mean, what the entire world know, like what they call as hacker, used to call hackers, but now they have corrected themselves. Crackers are the people who do bad things. So that's it. There is not much setup or anything that you see here. The only thing of importance to you here is, one, we have extended from some Clojure object, and if you look at initialize, we are doing initialization inside of a block passed to the doSync function. Okay, that's the part that is of importance here. The doSync will wrap whatever you ask it to do inside of a transaction. So if anything fails within that transaction, all the original state of the variables in this class would be retained. Right? So now if I try to withdraw amount from a bank, I need to do it in a transaction. If I deposit, I need to do it in a transaction. If I need to do transfer between account 1 and account 2, some money from here and there, even that needs to happen in a transaction. Yes, it starts and ends. It does both. I'm sorry. Oh yeah, okay. The do sync does. I understood what you asked. The do sync is not called anywhere except for the initialization. But whoever works with the account is going to have a do sync outside. Because let's say I want to, so I have to maintain that transaction, and if I have 10 accounts to do something with, it doesn't make sense to have a transaction within a single account. So only the initialization here is within the do sync thing, because the variable that the state that I have inside needs to be in a transaction and safe. So let me create two accounts with an initial deposit of 1000 something. Okay. All right. So account 1 dot balance 1000, and similarly 2 is 1000. I can access the data without having to have a transaction. Okay. That's read only stuff is pretty straightforward. No transaction running. Right. So all I need to do is surround this in a do sync. 10 rupees out. Now how about this? I want to transfer money from account 1 to account 2. I need to do that in a transaction, and I try to do something which is bad. So just to so you see account 1 has 990. Okay, now let's try and transfer 1000 from account 1 to account 2. I call account 2 by itself, deposit some amount, withdraw something from account 1, one after the other. An exception was raised. And what are the values that you have? 1 is still 990 and 2 is still 1000. 5 minutes only. Only 5 minutes. Oh. Okay. So just take my word for it that if I do the right thing here, the transaction will pass. Let's move on quickly to was it 5 minutes? It should be until 2:30, right? It started at 1:45, right? Oh, okay. Okay, we have time, unless you're bored. So before going to Scala, I just want to quickly show you, how this thing is done. How do you write a wrapper on an existing Java library for use uh, in a Ruby-esque manner, right, from JRuby? So, like all the good points apart, here is the. I've removed all logic, all code except for the most interesting bits. If it is not visible, I think this is better, right? All right. So there's a Clojure library which implements the library interface, which is part of JRuby. All you need to do is implement the load method. The load method is supplied the Ruby runtime and something that I don't know, and Charles can answer after the talk. He volunteers, module, you define a module called Clojure. Under module, you define a class called object. Alright. So if you now connect this with the Ruby code we had, we extended from Clojure colon object. Right? Do you remember, or do you want me to show that code again? Yes, no, sleepy? 3 options, like which ones? 50-50. So, in the interest of time, I should just quickly repeat that we had a class in Ruby which extended from Clojure colon object. Alright? That is what gave our Clojure class, sorry, our Ruby class some Clojure underpinnings. Right? Here is how that thing, that magic happened. This is implemented the following way. You define a module called Clojure. Under that module, the runtime.define class under CLJ module, which is the last argument there, and you have an allocator which allocates all instances that you are going to use. The last line that you see, runtime.getKernel.define annotated methods. So if you look at the doSync method, that was not on any object. The doSync was a standalone method, right? Of course, Java doesn't give you standalone methods, standalone functions. No, right? So the way to do it is you annotate your methods in Java with this thing called JRuby method. If you see this JRuby method, now you notice that this is static class, static method inside of it. It's as good as a function for you, just namespace, name scope, whatever. And the name is exactly the same, doSync. And that's what is available to you as is in Clojure, Ruby. Right? So, by the way, like all of this code is in the Clojure gem, available for you, the power fun of open source. Oh, sure. All right. So you get the idea here, right? So there are a lot of there's a lot of code lying there. This is very simple, very easy, really. I mean, if you just get the few things here and there which Java unfortunately will force you to do, you can actually adapt a lot of your Java code to, or Clojure, or even like the Scala code to Ruby, and that this is one-time pain mostly. All right. All right. We go to. Sorry. Here. So Scala is, as you know, blah blah, immutable, persistent data structures again, type safe, good inferencing, very expressive, compiles to bytecode, blah blah blah, right? All of that. And I'll show you a nice example, which I'll let you clap after that. It's okay. Guys, please laugh. I make jokes. I know they're bad, but at least gives me some feedback. Yeah. All right. Here, this range is a Scala class. All right. And you can see this code, right? Range is Scala class. I do range.new 1 to 10, step 1, and then for each, just print the value of I. No surprises. But that is a Scala class. Alright? Now Scala has something called parallel collections. And the way it is done, they've made it very easy for you to use. So look at what we can do. All we need to do is, at the end of the creation of the range object, I just add a short form for parallelize, par, and look at what comes out. All parallelized, individual threads printing out individual values. And you see obviously things mixing here and there because there is buffering and blah blah blah. So new lines will come together and all that stuff, right? But here is the thing. I want to show you actors. I have two actors, and I will simply show you the calculation of pi done in parallel. I have already imported that class. I want to create 8 worker threads. So 8, 100 messages and 100 slots. That's a very bad approximation, but it does some calculation. What is happening behind the scenes is that work is being parallelized by something called actors. So quickly, what actors are actors are another nice concurrency tool which were no, which was brought in by Erlang. The idea of actors is you have an entity which is called an actor, which acts or does something. That something is some computation task that you can hand over to it. Now, if the task that I do is fairly independent and self-contained, I can have as many actors as I want, let them do all this stuff, and then there should be coordination in the beginning. So there is no sharing of any data while computation happens, and data like you collect all of the data and then you're done. Those are the kind of problems that actors will make it easy for you to do. So Scala has brought in actors as a first class member of the Scala family. And now what this is the Akka library, which is going to be part of the Scala ecosystem starting from 2.10. Okay, so how much time? We're out of time. So I really wanted to show you some code that that would have made sense, but I really don't know whether here if you see this code, this is just take my word for it. This is working actor code written in Ruby by importing a few jars from the Scala land. All we need to do is extend from untyped actor, and there are multiple kinds of actors depending on what kind of work you're doing, and implement an on receive method. Right? I create an actor system which has its own pool of workers running. Send off a message to it. The actor would respond to that, would work on that message. If there is something to be returned, you have a handle back. If you don't want to, you want to do fire and forget, you have a way of doing that as well. So I think I'm going to stop here and just take a few questions as much as time permits, and then
We actually don't have any time, but it wouldn't be fair.
yeah, and I can
Take on one question and the rest, please take it offline.
yeah.
Can you show us the implementation of calculate method? That
The implementation,
of the calculate.
I will definitely show it to you just after the. This. Is that the only question? That was not a question. Okay. Thank you.